So, this relates a little to an idea we've recently done. This is an improper integral. It's not the only improper integral. I mean, we could have ease and interchange. There's a lot of different improper integrals. But this is a special improper integral that we're going to focus on. We talked a couple days ago about how this converges, yes or no. Well, does it converge, yes or no? Okay, P is greater than this or that. It depends. Depends on P, all right? If, depends, okay? If P is, what's the great dividing line? 1, yeah. If P is greater than 1, for example, 1 over x squared, then when you integrate it, it's 1 over x-ish. And as x goes to infinity, this converges, yeah? Okay, because x, even after integrating, is still in the denominator. But if P is less than 1, for example, 1 over the square root of x, or x to the negative 1/2, then when you integrate that, it ends up in the numerator. And as x goes to infinity, this diverges. So P of 1 is the great dividing line. Now the question obviously is, what about at 1? Yes or no? Diverge or converge? Diverge. Why? It results in a natural log, which also would grow infinitely large. So P less than or equal to 1 diverges, and P greater than 1 converges. Now let's take that to series. There's a lot of overlap or similarities between integrals and these series that we've been talking about, right? There's a lot of, yes ma'am, sorry.
What about if it's for a positive fraction?
A what?
Like a positive fraction.
Good question. It would still be like this. What do you mean? Like this?
Yeah.
Still one, the dividing line of 1 still works, because even that's actually this, isn't it? So it's the same. It doesn't matter. Doesn't matter. Okay. Now, how the similarities work. The integrals in series are similar because they both involve infinite sums. All right. We know obviously these series involve infinite sums, but integrals came from infinite sums. They were infinite Riemann sums of rectangles taken thinner and thinner, but adding more and more heights. Right. So they both involve infinite sums. They're a little different, however, in the nature of the numbers. Integrals, because integrals are all reals. Okay, I don't say x, let's look at that. Our x is a non-number of reals. When I integrate 1 over x, x can be a half, and x can be a fourth, and x can be a tenth, and x can be whatever else. It's all real numbers. But for series, you're dealing with, when you're dealing with functions of n is only integers. So the nature of the numbers is slightly different, but they're still involving sums. Just what kind of numbers? All right, you with me? Now, because there's so much overlap, they behave similarly in a lot of ways. In fact, one of the most powerful tests you have is called the integral test. We'll deal with that next week. But this series is like this integral. Instead of dealing with x's on a graph, we're dealing with n's, whole numbers that count. You with me? But the idea of the fraction is still the same, and infinitely large is still the same. So there's a lot of similarity, like we just talked about. And they'll behave the same way. Now this series, that's a p-series. A p-series is just a nature of 1 over n to some power. Now when you actually get a exact problem, p will be a number. All right? N always stays in, but the p will be defined. So you might have a series of 1 over n squared. That's a p-series with p equal to. You could have 1 over the square root of it, where p would be 1/2, and so on. You with me? So n stays in, p will be defined problem by problem. Are you with me? Are you with me? Okay. All right. Well then, The same is true for the integral as we talked about for the series. This will converge if p is greater than 1. Now, you can also think that would force the terms to get small fast. If you took 1 over n squared, you're going to get small really fast. And that's what makes adding infinitely many of them possible, because they're so small and approaching 0 so fast. But if p is less than or equal to 1, then they get smaller. It still passes divergence theorem, but they get small slowly, and the sum gets infinitely large. That's equal to. Are you with me? All right. Bit of vocabulary. This is the most famous series of all. The p series, where the power is just a 1, is called the harmonic series. And the harmonic series converges or diverges? Diverges. You can see less than or equal to diverges. It's equal to, so it diverges. The harmonic series diverges. We played around with that a little in the calculator and showed it continuously. It just goes real slow, but never tops out. All right. Well, the problems of these on the homework really, like 20-second easy. Okay? They look like this. Does the series converge? Justify. Well, the first thing you do, remember there are lots of different series. There's geometric, there's p-series, there's telescoping. There's lots of different series. The first thing you do is tell the reader, hey, this is a p-series. I'm identifying what kind it is. Then you identify the test value. In this case, p equals 3. Then you identify the test criteria. P equals 3 is greater than 1, so the series converges or diverges? Converges. The series converges. I guess good grammar would be that, so the series converges, but I just write so converges. Most people do. Okay? Is that easier or what? Yeah. Try this one, please. By the way, the fact that a p-series doesn't start at 1, it doesn't matter at all. Okay?
So if we were to declare the p-series, would you just give a 0 and a
You would not give it a 0. You'd probably, on a homework, I'd probably just write you a note. On a test, I'd probably make it 3 points. Identifies p-series, maybe even 4. Identifies p-series, identifies p, shows the test value of 1, claims convergence. So you'd lose a point out of 3.
So it's not on the equal test?
This wouldn't be a free response. It would be a multiple choice, which I'll show you. Yes, ma'am.
What if it wasn't like a 1 on the top? Is it not a p-series?
Oh, no, that doesn't matter either. Good question. I should put that in my notes. That doesn't matter either. Remember, this, if I were to expand, so that's a good question in terms of really understanding things. Okay, remember, if I were to expand this, this means, right? So in terms of this, any number that's up there, it can be brought up front. And so I could, if there was 2 up there, I could bring it up front and call it 1, make it 1. Like that. Okay, so what do you say? This is or is not a p-series? It is a p-series with p equal 4/3 or 3/4? 3/4, which is less than or equal to 1, so this series diverges. You follow?
Yep.
Okay, now the rest of this is AP kind of multiple choicey practice. Should take you maybe 5 to 10 minutes. I'll give you time. Feel free to talk them over, and we'll go over them in a little bit. that you guys actually put comments when you get these back. I'm just looking at the score. It's incredible. I didn't do any comments on these, but it's nice that you look. Work. Exactly. It's my job to make sure that you understand which way.
Like one day you didn't understand it, it's either or. I was like, what does that mean? It's like, and I was like, yeah, but like, it's not just legitimate, but it's either or. I was like, I don't understand. No, and then she was like, okay.
Yes, sir.
He's off the side. Oh, it's Simonton Collins for him just C circle with cross. I don't really know how to do
N-1.
Wait, R is one.
Oh,
How do you know what I was supposed to do?
now I understand why you did that. You were thinking acceleration is the second derivative. Yeah, that's not. Sorry, you're looking for a vector. You're looking for a vector, so it should be x double y double in vector form. This is more like the second derivative of the curve itself. So now it's anyway, erase my mind. I'm good. Now I understand your thought process, which was wrong.
It has to be 4
One's like 1.5. It's not linear, it's just and 3 words.
Oh, skip 8, please. Scratch 8. That's really crazy telescoping. That's not necessary.
Oh, that looks horrible.
Yeah, it'd be a 6-term partial sum formula. We don't need that.
Yeah, I'm okay. I don't understand. What's number 3?
What's number 3?
Wait for 2 to 7. Sorry.
I didn't know when it converts.
Why it just goes to 1?
Hey, you just reminded me of something. In geometric and telescoping, after you say converges, you then usually find what it sums to. You don't do that in most series, and you definitely don't do this in P-series. There is no formula. There are rational numbers that go forever, don't repeat. So you don't usually go to what it converges to. You just say it converges. And if you wanted to estimate, you pick up your calculator and do a partial.
Fantastic.
Okay. The 220s,
Wait, is that negative?
It does go in.
Everybody's different. I imagine a lot of you are smart enough to do these kind of mental gymnastics on a problem like this. You could probably, like Cece was able to say, how you can bring this down and combine the exponents. But if you will probably be able to do that because you're that smart. But I am going to show you a really structured, kind of never fails approach to it. And if you want to cut steps out, so be it. So my purpose or my goal is always to get it to this. And then once I'm there, boom, I'm home free. I know my test. I'm done. Okay. So I would wouldn't you say that what's counting each time is that guy? And so that is n. X is up there. And so if I wanted to make this more of a p-series, then it would be more like 1 over n to the negative x, yeah? All right then. I know that this converges if negative x is greater than 1. So that means x must be, now remember you're going to have a lot of inequality work in this class. Okay, so you remember you know your rules. When you divide by negative, you switch the sign. So it's less than negative. Yes? You do not have to do any of this work. If you can just see it, more power to you. This will be multiple choice in each. As far as what a free response will look like for series, we're not close yet. We still have a long way. Okay. So x is less than negative 1 is B. Wait. Okay. This bad boy. This you have to, for a while, you just have to take your time. Make sure you know, is it P or is it geometric? This is counting. It is there. So boom. Is that a P series? Yes. And what's P? Yeah. P equals 2 is greater than 1. So this is a converge. Now again, on a multiple choice, you wouldn't necessarily have to show the justification. The homeworks will say justify, and so you'd show all this. But for now, if you can just say converges, boom. Okay. How about this one? Diverges because it's harmonic. Okay. You'll find also on the homework, you could do the P-series justification, but you could also say this diverges because it's the harmonic series, and it's an accepted fact that happens. This P-series, yay or nay? No, this is not arithmetic. Geometric, what's R?
Negative 1/3.
Negative 1/3. And that is less than 1, so this converges. So we choose 1 and 3. The answer is C. Okay? For, where did my key go? For this guy, what do you say? K is?
Greater than 2.
I say greater than 3. But I could be wrong.
I got grade. No,
I got grade.
Okay, so I would do this something like n comes down, this guy is n to the k plus 1 all over 2 because of the root. So one big fat exponent is n to the k plus 1 over 2 minus 1. Can you follow? Okay. K plus 1 over 2 minus 1 must be greater than 1 for this to converge, which means k plus 1 over 2 must be greater than 2. K plus 1 must be greater than 4, so k is greater than 3. Okay? All right, then. How about this one? Converge, diverge. It is diverge. Let's see. Okay? Is this geometric or P-series? Geometric. Technically, right now, it's a P-series, but the minute they put power series, rather. But once they put 1 in, it becomes numerical, and you've got a geometric series. It looks like this. Tangent of 1 to the n. This is a constant to the n. The next thing we need to do is, what is r? What is r? What's tangent of 1? 1.557. That is greater than 1, so this diverges. Okay? All right. This one was, I like this one. This had a little funky monkey business in there. What'd you get for this? It is indeed A. Do we need to talk about that? Yes. Okay. So, first thing you need to wade through is that this, the way I've taught you and the way most books teach you is you use S for partial sums. In this case, however, they say S does not represent partial sums. It represents the sequence. So it's really A sub n. They're saying this is terms in a list that aren't even being added. Okay. So if this sequence converges, that means there's a limit to the terms. They're just calling them S sub n in this case. So I need to establish the end behavior to this. I think we're all probably fine there, yeah? The real question is, what about the threes? Well, wouldn't it be great if those threes were gone? How can we make them gone? You could break it up in a lot of ways. This is how I did it. 3 to the n minus 1 is the same as 3 to the n times 3 to the negative 1, yeah? The minute you do that, gone. And now you have 1/3, and the top would be, I know the 7's there, and they're trying to get you to look at it first, pretty crafty putting it first, but really isn't the start of the show n to the 20th and on down. And in the bottom, the start of the show is n to the 20th on down. Those are equivalent powers, so this approaches 1/3. Right? Are you with me? Okay. This was ugly, it's telescoping, but like I said, this summation formula is something like 6 terms long, so it's not worth it. Anytime, just so you know, anytime there's a big gap between these two guys, you're headed for a long partial sum formula, okay? So you don't want to go there. This has a power, this is, looks like square root of increasing numbers to the k. That's n to the k over 2. In a p-series form, that's 1 over n to the negative k over 2. Yeah? Are you with me? As a p-series, it will converge if negative k over 2 is greater than 1. That would mean that negative k is greater than 2, so k is less than, the sign switches when you divide by negative, less than negative 2. Did you get that? Cool. And this, p-series or geometric? P-series, 1 over n to the cubed, or 3. And that, therefore, is a p-series with p equal 3. So this, which is greater than 1, so this converges. Sweet. And the last one, p-series or geometric? P-series, 1 over n to the, what do you got there? 2/3. Yeah, 2/3, I'm down. Okay, 2/3. It's a p-series. P equals 2/3, which is less than or equal to 1, so this backwards. All right, you get it? Okay. Let's do the DuPont. Questions on 126. 25.
7.
Yeah. 7? 20?
21.
Yeah, that's not the approach. What else? 25, 7?
21.
21?
23.
23? Alrighty, those 20s are rough. Perhaps you're running out of steam. Or maybe they're just harder, I don't know. Okay.
I just did 12.
Okay. Before I get to this details, tell me 2 things you know about odd functions. Symmetric about the origin, true. What about analytically? P of negative x must equal negative p of x. Okay. If you have those ideas in your brain, then this will go better. Imagine a function that was odd. Like this. Oops, that was supposed to be through the origin. Or sine, like this, yeah? Cool? What's the y-intercept on both of those? 0, yes? What happens if you tack on a y-intercept? Your symmetry is toast. It is no longer off, okay? So what does that tell you? D must be 0. No way. You cannot have a y-intercept of anything but 0 on an odd function, otherwise it will not come out the same. It also tells you what b must be. What must b be? B must also be 0. In order for this to be odd, if you were to put in negatives, you would have to be able to factor out a negative, and the only way that's going to happen is if every single one changes sign. This one will change sign. This one will change sign. But this one will not. Okay, so B must be 0. B and D 0. Now we're ready to move on to finding C. Please don't think you can find a numerical C. You cannot. You're going to be finding C in terms of some cube stuff. All right? Do you see it from here, or should we continue? Continue. Okay. If there are extrema at x equal plus or minus q, then it must be the case that p prime equals 0 at plus or minus q. It can't be a DNE kind of undefined critical number because it's a polynomial. There are no undefined degrees. There really are. There are points on a polynomial. All right. So I'm going to take yield derivative, which is 3x squared plus c, and say that when I put in a q, giving me 3q squared plus c, it must equal 0, and therefore c is negative 3q squared. And yeah, I agree.
Question.
Yep.
How did you know B was 0 again?
The only way for this to be odd is if this guy isn't there at all, because it behaves in an even fashion. Remember, odd means that when you put in a negative, every sign or the overall sign changes. And on a problem like this, that's only going to happen if you can factor a negative out, meaning every one has to turn negative. Well, when I put in a negative here, that one will change signs. But when I put in a negative there, that one will not change signs. And so it won't be. Because of that, it will not be the opposite of what it was. Okay?
Okay.
All right. 7. Is 7 still a question?
Yeah.
7.
Well, it's also like just how to anti-differentiate 1 over x squared plus 2.
I would do a quick arctangent, not a trig subarctangent. So 1 over the end. Did you say the numerator was 1?
Yeah.
Okay. I would call this 1/2 of 1 over x squared over 2 plus 1.
Yeah.
That means in the arctangent formula, u squared is x squared over 2. So u is x over root 2. And du is 1 over root 2 dx. So dx is root 2 du. Yeah. Okay. So in some kind of, but if you want to actually then use sub this, then it would be something like 1/2 root 2 1 over u squared plus 1 du. So it's root 2 over 2 arctangent of x over root 2.
Okay.
If you can do that without that works fine, but if that's what it takes, fine. Okay? All right. 21.
I got it.
You got it. You talking to me? Oh, okay. Does anybody need 21? Oh, okay. Alrighty then. 4 over. So, did you trig sub this? Did you let x equal 2 secant theta? Oh, maybe you should.
I did arc secant, so
Oh. So, I mean, do you have that memorized? I don't either. Oh, that's fine. You can use it, but you need to know how to adapt the table of integrals. Do you want to talk about how to adapt to a table of integrals?
Is that
So it's when you look up the basic idea in the back of the book. Every calc book has hundreds of tables of integrals, and you figure out, all right, how do I adapt my problem to this situation? It's a useful skill in college. I guess you looked up.
Why can't you just or I mean, say it like it's one C, and then that leads into a tangent.
No, because you have to put it, you have to.
You don't have that for?
Yeah, you pull out the 2, and then it ends up as 2, like this. No, because you just plug in secant equations, or 2 secant things, and it's still the same as Sorry, I mean, yeah, but why don't you look at
Oh, she looked at something like something else.
no, it's not that.
She said like art based. So, 23.
Divided by 4. For 23. Your DU, in this case, your DU,
Oh, that doesn't
your
look right.
U is x.
You feel pi for A, for 2.
So DU is 1 over 2.
No, stop. No, I was just saying I'm not doing number 8. Oh, number 2. A. Oh, you haven't. Oh, no, sorry. I just told you to jump into that one with the open part. Dude, 2 is so easy. Big box. That's true.
How I see the big boxes first.
I was like, you did a big boxes first.
I did a higher one first, so then the little ones go back. And I'm like, look, I'm so productive. I just like,
No, see, I need like the motive, like, I need like activation energy.
Gotcha. Guys. Alan,
He's scientific.
Alan, please stop.
Learn science. All enzymes. All enzymes. Hey, wait, what was that thing that mysterious thing?
How did they get?
There's the old thing like not all drafts are animals. Not or all animals are drafts, not all animals are, not all drafts are animals.
Oh, all giraffes are and
No,
not
I feel
all.
like Mr. Ace is from that, and this is something else.
Wait, who's searching around?
Mr. Ray.
Oh,
He's
yeah. All animals are giraffes.
not all giraffes are animals.
What does that even
Okay.
mean?
I know.
23. Is 23 still a question?
I haven't gotten to being super.
Oh, 23 and 24 are companions. Do you understand? Did you see those together? See how they're brothers or sisters, whatever? Okay, 23 and 24 together are a big idea of calculus. And a really fine point. So let's talk about 23 versus 24. 23 is a particle moves along the x-axis and position is given this way. And they want distance on -2 to 5. X-axis -2 to time equal 5. In 24, they say a particle moves along the xy plane. The path is given by y equals x squared minus 3x minus 4. What's the distance the particle travels from x equal -2 to x equal 5? You can see obviously they're very similar, yes? Okay. If I were to graph the movement here, the path it travels would look like this, yes? I don't know where it is, but yeah? So if I found the length of this curve, wouldn't I be also finding how far it went? All right, because this graph represents the path. Finding the arc length is equal to the distance traveled. However, this, I could graph it and I get a parabola and all that, but is that the path of movement? No, it moves linearly along the x-axis. This is not what the movement looks like. This just describes position at time, saying it, here it's x, and here x is this, and it's moving this way back and forth. So to find the arc length here, it's not finding this, you're not finding anything. Yes?
How do you show the work for, you just write like this equals x of 5?
So yeah, we call the two ways. If it's calculator active, how do you show linear distance? How do you calculate linear distance? Go back way in your basics.
Integral of velocity.
Integral of velocity or speed?
Or speed.
Speed. Integral of speed. That's it. Boom, calculate. Now, if you didn't have I don't care if you use a calculator. You can use that. If you don't have your calculator, then you have to find where it changes direction and say, oh, at 3/2, and then you got to do all that piecework. I don't care either way. If you want to do that for practice, great. But you may use your calculator. Okay? That's it. Other question?
I know it's not a trick, so.
All righty then. Let me know how I can help you. Let me pause this recording.